28 million pounds. Say it slow, and it still doesn't land right, because nothing in ordinary life weighs 28 million pounds. 14,000 tons of hardened steel, standing 210 feet tall, and for 26 years, exactly 4 human beings were trusted to run it. 4. Not 400, not 40. 4 men climbed a ladder and an elevator every shift, sat down inside a machine bigger than most office buildings, and moved the earth around like it owed them money. It did not dig the way you picture digging. It bit. One pull of the cable, and a bucket the size of a 2-car garage tore out 270 tons of rock in a single motion, swung it clear, and dropped it 150 feet away before the dust from the first bite had even settled. It ran on 14,000 volts of raw current, converted and fed through 20 electric motors that together could have lit a small city. It was born in a machine shop in Marion, Ohio, a town that had spent 80 years perfecting exactly one obsession: building the machine that could outdig every machine that came before it. And somewhere in that obsession, something got left behind, because for all its steel, for all its voltage, for all its 26 years of swallowing hillsides whole, this machine did not go down fighting a mountain, or a flood, or a rival company's bigger shovel. It went down because of a length of rubber hose no thicker than a man's wrist. That's the part nobody believes the first time they hear it. The biggest machine on the planet, brought to its knees in a single night by something you could buy at a hardware store. This is the story of Marion Power Shovel, the Ohio company that spent the better part of a century chasing bigger, until bigger finally caught up with them. It's the story of a machine called the Captain, built to strip 2 coal seams at once, with a bucket that could swallow a house. And it's the story of the 4 men who were still standing on it the night the fire started, and the climb one of them made, 21 stories above a pit floor, just to stay alive. How do you run something the size of an apartment block with 4 pairs of hands? What happens when a fire breaks out 30 feet up a machine with no fire escape and no ladder in the county tall enough to reach it? And how does the largest machine on earth end up killed by something you could buy off a shelf at a hardware store? Stay with this one. The ending is not what you expect from a machine this big. The facts that don't sound real. Start here, because none of this sounds real until somebody walks you through it, and nobody is walking you through anything yet. Stand next to the Captain and try the math on your own body. It weighed as much as roughly 9,000 pickup trucks. Picture a 19-story building, torn loose from its foundation hole, and taught to crawl toward you at a 1/4 mile an hour, slow enough that you could outwalk it without trying, heavy enough that you would never want to test that. 210 feet of it stood on 8 crawler tracks, each one longer than a school bus, each individual shoe on those tracks weighing 3¼ tons. 336 of those shoes touched the ground at any given moment, spreading 28 million pounds, thin enough that the machine could keep crawling forward without sinking into the very earth it was built to tear apart. Stand under one of those tracks by accident, and you would not be a person anymore. You would be a stain. Its bucket held 180 cubic yards, 300 tons in a single bite, and it needed 2 separate doors just to dump that load, because one door that size would have torn its own hinges apart trying to swing alone. Each of those 2 doors weighed 15 tons on its own, more than most of the coal trucks working the same pit. It ate enough electricity in a single shift to power an entire town of 30,000 people. Not run their appliances. Power the town. Lights, furnaces, factories, streetlights, all of it. And this machine burned through that much current just to swing 1 bucket back and forth across a coal seam in Illinois. So how do you keep a city's worth of electricity from killing the men standing 3 feet away from it? Very carefully. Not always successfully, but we will get to that. One operator, alone at the controls, once dug a full mile of pit, start to finish, in 10 days. Not 100 men with picks and mule teams. One man moving more earth in a single shift than entire construction crews managed in a season 50 years earlier. Over its full working life, This one machine moved 809 million cubic yards of rock, enough displaced earth to bury a mid-sized American city under several feet of dirt. 26 years. One machine, a number so large that the people who tracked it eventually just stopped saying it out loud, because saying it out loud made it sound made up. And underneath all of that production sat something nobody liked to think about too hard. 10,000 gallons of hydraulic fluid, 1,000 gallons of diesel, 1,000 gallons of solvent, half a ton of grease, all of it packed into the same structure that carried 14,000 volts through its own frame like a nervous system. Every giant machine of this era was, in a sense, sitting on top of its own worst-case scenario the entire time it worked. Nobody said that out loud on the job. Everybody who climbed inside it every morning knew it anyway. And here is the fact that should stop you cold. This 28 million pound machine, this beast that could outdig an army, answered to exactly 4 people. An operator, an oiler, a welder, and one man on the ground below, watching a single trailing cable, because if that cable failed, everything above it failed with it. 4 people. Hold on to that, because it is not just a strange fact about staffing. It is the entire reason this machine could burn to the ground in a single night, with almost no chance to stop it. Build something this massive, hand its survival to 4 sets of hands, and you are betting the whole machine on those 4 people getting everything right, every single shift, for as long as it lives. Nobody ever built in a backup plan for the one day they couldn't. The factory that couldn't stop building bigger. To understand how a company ends up building something this reckless in its own quiet way, you have to go back 81 years earlier, to a much smaller problem in a much smaller town. In 1884, 3 men in Marion, Ohio, decided the shovel wasn't good enough, and refused to just live with that. Henry Barnhart had a design, a steam-powered digging machine with a stronger bucket support than anything else on the market, patented the year before. But a patent doesn't build a factory, and Barnhart had no money of his own to prove the idea worked. He needed someone willing to bet real cash on a drawing instead of a sure thing, and he found that person in Edward Huber, a local businessman with enough nerve to back an unproven machine. Together with George King, the 3 of them founded the Marion Steam Shovel Company and staked the whole town's future on a bet that somebody, somewhere, would pay real money to stop digging by hand. The problem they were solving was brutal in its simplicity. Before machines like theirs, moving earth meant men with picks, shovels, and mule teams, weeks of back-breaking labor for jobs a machine could finish in days. Railroads needed grading. Cities needed foundations. Somebody, somewhere, was going to build the machine that made all that hand labor obsolete. Marion decided it would be them, and if the machine failed, there was no fallback plan. It worked, faster than anyone in that farm town had any right to expect. Marion, Ohio wasn't a rail hub or a port city. It was corn and soybean country. But Barnhart's design was good enough that rival machine builders started setting up shop within walking distance just to compete with it. Osgood Steam Shovel, Fairbanks, General Excavating, and 15 miles down the road, a company called Bucyrus, close enough that its factory whistle could practically be heard from Marion's own floor. Bucyrus eventually packed up and moved to Wisconsin after local officials refused to let them expand, handing Marion an open run at its own backyard for the next several decades. But an open run isn't the same as an easy one. Bucyrus never stopped chasing, and from that point forward, neither did Marion. By 1911, 90% of every large steam shovel and dragline built in America came out of that stretch of Ohio farmland. 24 of Marion's machines dug the Panama Canal, and one of them set a record in 1908 that stood for years, moving over 53,000 cubic yards of earth in 25 working days. Their shovels tore through rock for the Hoover Dam, for the Holland Tunnel, for a subway line stretching into Queens. A town of a few thousand people had somehow become the excavation capital of the industrial world. And every year, The machines coming off their floor got bigger, because bigger was the only answer the market ever seemed to want. So what happens when bigger stops being a boast and starts being a demand you can't say no to without losing the contract to the company down the road? You keep building, and you hope the engineering catches up before the ambition outruns it. Bigger machines needed bigger crews, bigger power sources, bigger everything, until the company ran headfirst into a problem nobody in 1884 could have predicted. Steam itself was the first thing to go. By the 1930s, diesel and electric power had made the steam shovel obsolete, and in 1946, the company changed its own name to match, Marion Power Shovel, no longer just steam. Then came coal, and coal wanted something else entirely. Not a machine that could dig a foundation, but a machine that could strip an entire hillside bare in a single pass, fast enough to keep a power plant fed around the clock, every single day, for decades. And every time Marion built one that could, the industry came back wanting one bigger still. By 1956, that chase had produced the Mountaineer, 16 stories of shovel that broke every size record before it. It should have been the ceiling. It wasn't. Bucyrus, the old rival from down the road, was chasing that exact same record with giants of its own, and neither company was willing to let the other hold the title of biggest shovel on earth for long. Marion kept building, kept scaling, kept answering every demand for more, with an answer nobody had dared attempt before, right up until 1965, when the coal company Southwestern Illinois came to them with a job that would push the entire concept of a power shovel past what anyone thought steel could carry. They didn't just want a big machine. They wanted one shovel that could strip 2 coal seams at the same time, on 2 different levels, without ever stopping to reposition. Most engineers would have called that impossible on paper. Marion built it anyway, and gave it a name that sounded almost gentle for something this violent. They called it the Captain, after Thomas Mullins, a pioneer of surface mining whose son was now running the company that had ordered the machine. It would take 10 months of round-the-clock construction just to put it together on site, 7 days a week. Welders and riggers working high steel, with no guarantee the design would even hold once its own weight came fully to bear, because nobody had ever tried to stand a structure this heavy up off the ground before. When it finally stood upright in that Illinois pit in October of 1965, it was, without argument, the largest machine that had ever moved on its own power across the surface of the earth. It cost $25 million to build. That same year, a Las Vegas casino called Caesar's Palace opened its doors for almost exactly the same price. One was built to entertain gamblers, the other was built to eat mountains for a living. The machine that had to survive itself. Building something this big isn't really an engineering problem. It's a survival problem, because at this scale, the machine's own weight becomes its worst enemy, and every system inside it exists to keep 28 million pounds from tearing itself apart. Start with the simplest question. How do you even move something this heavy without it sinking straight into the ground? The answer was 8 separate crawler assemblies, each 45 feet long, each one carrying 42 individual track shoes, 10 feet wide. Spread the weight across enough steel, and even 14,000 tons becomes survivable, distributing barely 60 pounds of pressure per square inch, less than a parked pickup truck. But that spread came at a cost. All that surface area meant the captain could only crawl forward at a quarter mile per hour. It could outdig anything on Earth, and it moved slower than a man could walk. Then there's the power problem. A machine this size can't run on diesel engines the way smaller shovels do. There simply isn't a combustion engine on Earth built to survive that kind of sustained load. So Marion's engineers went electric, feeding 14,000 volts of alternating current down a trailing cable into 4 massive generator sets, which converted it into direct current for 20 separate drive motors. 8 motors just for hoisting the bucket. 8 more for swinging the upper works around on its turntable. 4 to crowd the dipper handle forward into the rock face. 16 more, buried in the crawler assemblies themselves, just to inch the whole structure forward. Follow that power all the way through the machine, and you start to understand why 4 people were ever considered enough to run it. Current came down the trailing cable at 14,000 volts, dropped into the generator sets, converted to direct current, and split out to 20 separate motors, each one dedicated to a single job and nothing else. Hoist motors did nothing but lift. Swing motors did nothing but rotate the upper works. Crowd motors did nothing but drive the dipper handle forward into the rock face. One chain, one direction, current in, motion out, repeated thousands of times a day without a single moving part, doing double duty. It was elegant, in the way only something built at an unreasonable scale can be elegant. But feeding that much voltage into one machine creates its own danger, one that had nothing to do with rock or weather. 14,000 volts doesn't forgive mistakes. It doesn't care if you're tired, or rushed, or 3 hours into a double shift. One exposed wire, one failed insulator, and the same power that let this machine outwork an army could just as easily kill the men standing next to it. That tension, unbelievable capability, sitting one bad connection away from catastrophe, is not a footnote to this story. It is the story, and we are going to come back to it, because it is exactly what ended up happening one September evening in 1991. Now picture the bucket itself, because this is where the impossible math really shows up. 180 cubic yards, 18.5 feet wide at the mouth, 24 feet from front to back, 16 feet tall, a single bite of earth big enough to bury a delivery truck whole. To lift that kind of load, engineers ran 4 steel cables, each 3.5 inches thick, through a 2-part hoist rigged to 8 1,000 horsepower motors. Every single time that bucket rose out of the pit full, those cables were carrying 270 tons through the air on nothing but braided steel and physics. And here's the detail almost nobody expects. This machine was built to strip 2 coal seams simultaneously, walking directly on the lower seam while reaching sideways to strip the upper one nearly level with the operator's own cab. That meant the boom had to reach further, dig at a different angle, and dump higher than anything Marion had built before, a maximum height of 153 feet. Every inch of that reach put more strain on a 215-foot boom that was never allowed to fail. Not once, not for 26 years. It wasn't the only giant working that decade either. Down in Ohio, Marion's old rival Bucyrus was running its own monster, a dragline nicknamed Big Muskie that could outcast the captain on raw distance, hurling overburden clear across a valley instead of lifting it straight up. And Marion itself had a second contender waiting in the wings, a slightly smaller stripping shovel it called the Big Digger, working a mine in Kentucky with a 125 cubic yard bucket. But size for size, nothing matched the captain's combination of a dipper, the width of a house, and a boom built to strip 2 coal seams in a single working pass. It didn't need to be the fastest. It needed to be the machine that made every other approach look small by comparison. And for 26 years it was. So how do 4 men actually run something engineered at this level of complexity? The answer is the same answer that runs through every giant machine of this era. You don't eliminate the complexity, you specialize it, and you trust each specialist completely, because there's no time for a committee decision when 300 tons of rock is swinging through the air. The operator sat 5 stories above the deck, in a cab wired with fingertip and pedal controls, watching the dig cycle through reinforced glass, riding an elevator 8 stories tall just to reach his own seat every morning. The oiler crawled the machinery deck constantly, feeding grease into gear cases that would seize under load without it. The welder patched cracks and worn steel before they became failures, working with a torch a few feet from cables, carrying enough current to power a small town. And on the ground, one man alone kept watch over the trailing cable, the machine's electrical lifeline, running a wheel loader to keep debris clear so the cable never snagged, because if it tore, 28 million pounds of machine would go dark in an instant. 4 specialists, 4 separate failure points, and not one backup built in for any of them. That wasn't an oversight. It was the deal every giant machine like this made with the men who ran it. Build something bigger than anyone had ever attempted, and accept that its survival now rested on exactly 4 sets of hands getting it right, every shift, for as long as the machine lived. It worked, for 26 years. Until, on one ordinary evening, it didn't. The men who lived inside the beast. Running a machine like the captain wasn't a job you learned in a classroom. It was a job you survived, shift after shift, inside a structure that never stopped moving, never stopped roaring, and never once let you forget how much bigger it was than you. The crew worked 3 shifts, around the clock, 7 days a week, because a machine that expensive doesn't get to sleep. Coal doesn't care what time it is, and neither did the schedule built around this machine. Operator Gene Miller ran the afternoon shift for years, and by his own account, there was nothing quite like sitting inside her at full production. Crews who worked around the captain talked about her the way you'd talk about a big, stubborn animal instead of a pile of steel. She groaned before a heavy bite and settled with something close to a sigh once a long swing finished. Under Miller's hands, the captain routinely turned in more than 7,000 cubic yards an hour, numbers that made the machine practically a legend among the men who worked the mine. He once dug a full mile of pit, start to finish, in 10 days. On another stretch, where the overburden ran 100 feet thick, the captain finished the job in 5 days. When a smaller shovel eventually had to cover that exact same deep cut after the captain was gone, it took 11 days to do what the captain had done in 5. But production numbers don't capture what it actually felt like standing inside 28 million pounds of moving steel. The noise alone was constant. Motors, gears, hydraulic cylinders, the grinding of steel track against rock. All of it happening at once, all of it close enough to feel in your chest. The heat off the electrical equipment turned the machinery deck into an oven in summer, and in winter, the wind off an open Illinois pit cut straight through a work coat while a man clung to scaffolding 30 feet up, torch in hand, patching a crack before the next shift needed the machine back at full weight. And every single person on that crew knew, without needing to be told twice, that a mistake around 14,000 volts of live current didn't give second chances. You didn't lean on a rail you hadn't checked. You didn't assume a breaker was open just because someone said it was. The oiler's job never really ended. Grease had to reach every gear case, every bearing, every joint under load, constantly, because a machine moving 300 tons per byte generates friction that would tear dry steel apart in hours, not days. Skip a lubrication round, and a gear case could seize mid-swing, with 270 tons of rock hanging off the end of the boom when it happened. The welder patched what the machine's own weight tried to crack open. Steel plate, structural joints, anything showing stress before it became failure. Because a machine this size doesn't crack quietly. It cracks catastrophically, all at once, usually under load, usually at the worst possible moment. And the ground man walked beneath the whole structure watching one cable, clearing rock and debris with a wheel loader so the trailing line never snagged, because that cable was the only thing connecting this monster to the power that kept it alive. And a single tear could black out the entire machine mid-swing, stranding a bucket full of rock in mid-air, with nowhere to put it down. So what actually held 4 near strangers together on a machine that could kill any one of them in half a second of inattention? Not friendship, not at first. Trust, earned the slow way, one shift at a time, until each man simply knew, without needing to ask, that the other 3 had already checked what needed checking. There was no clocking out and forgetting about it either. The Captain mine sat out in rural Perry County, Illinois, a long way from anything resembling a city, and the men who ran this machine lived in that same stretch of farmland their whole working lives. Shift work like this didn't just wear on the body. It scrambled a person's sense of time entirely, cycling from daylight to midnight, to the dead hours before dawn and back again, week after week, year after year, all so a machine that never slept could keep being fed. What kept a crew like this steady wasn't excitement. It was routine, drilled in so deep that even a genuine emergency, at first, felt like just another problem to solve calmly, one extinguisher at a time. None of these men worked alone, not really. The machine forced them together, because no one person could see everything happening across 215 feet of boom and 8 stories of machinery house at once. When something needed fixing 30 feet above the ground, somebody had to climb to it. When smoke or sparks or a strange smell showed up anywhere on that structure, everybody stopped and went looking. Because on a machine that size, ignoring a small warning sign wasn't caution. It was a decision, and it was one this crew had made correctly, every single time, for 26 years running. That instinct, stop, investigate, don't assume it's nothing, is what these men did every single time something felt wrong. It had worked for 26 years. It was about to be tested in a way none of them had trained for, on a shift that started like every other shift before it. The night one hose brought down, the largest machine on Earth, September 9th, 1991. Afternoon shift, 4 in the evening to midnight. Nothing different about it, until roughly 7 o'clock, when operator Gene Miller caught a smell he didn't like, drifting up into the cab. It could have been a dozen things. A sticking brake shoe, an overheating bearing, a short in a motor winding somewhere in that maze of electrical equipment below him. Miller stopped the machine and climbed down with his oiler to find the source, because on a machine wired for 14,000 volts, you do not wait to see if a smell gets worse on its own. They found smoke rising from the lower works, and beneath it, hydraulic oil already burning. It's worth pausing on exactly what that meant. The captain's lower frame held 8,000 gallons of hydraulic fluid alone, feeding the giant cylinders that leveled and steered the machine. Add to that a 1,000-gallon diesel tank, 1,000 pounds of automatic grease, 1,000 gallons of solvent stored in drums, and you have a structure that was, in essence, sitting on top of its own fuel supply. A fire down there wasn't just a fire. It was a fire with everything it needed to keep growing. Miller, oiler Fred Kruger, and welder Gary Andrews grabbed the 20-pound dry chemical extinguishers mounted all over the machine and went at the flames immediately. There were dozens of those extinguishers positioned across the structure for exactly this reason. It wasn't enough. The fire grew faster than 3 men with hand extinguishers could keep up with, and Miller made the call to radio the mine office for help, while Andrews rode the elevator up to the roof to grab more extinguishers from storage. The mine's own fire trucks arrived first, carrying 200-pound extinguishers, and found them useless almost immediately. The fire was already 30 feet above the ground, wrapped around the lower frame, and there was no safe way to climb into that heat to fight it directly. So the call went out wider. Cutler's fire department first, reaching the mine office just before 10 that night. Then Pinckneyville, Percy, Campbell Hill, Steelville, Coulterville, DuQuoin, Sparta. Within hours, crews from 8 different towns were standing in a coal pit in the dark, fighting a fire on a machine none of them had ever trained for, because nothing like this machine existed anywhere else to train on. So who's actually in charge when the largest machine on Earth catches fire in the middle of nowhere? For the first half hour, nobody. Mine workers on shift tried to direct the response themselves, throwing out instructions that contradicted what the arriving fire crews were already doing. Nobody quite in command of a fire nobody had a manual for. In the confusion and the dark, one of the mine's own foremen drove off the exposed coal seam and rolled his truck. He walked away from it, shaken but unhurt. One more small danger stacked on top of the main one, still burning 30 feet in the air. It took the better part of that half hour before a proper command post finally came together inside a Steelville Fire Department vehicle, pulling the mine's own tankers, lifting equipment, and a boom truck with a man basket into one coordinated fight instead of 8 separate ones. And 30 feet above all of it, welder Gary Andrews was trapped. He'd made 3 separate trips up the elevator to bring down extinguishers, and on the third trip, the smoke beat him. Thick, black, and rising fast enough that it filled the machinery house and started climbing the elevator shaft itself. Andrews couldn't get back down. The ladders inside the house were already swallowed in smoke and heat too intense to enter. 21 stories up, alone, with the metal under his boots getting warmer by the minute, there was no version of this that felt like routine anymore. The electrical system had failed by then too, which, as strange as it sounds, may have saved his life, because it meant he wasn't caught riding a powered elevator when the current died. Instead, he was stuck on the roof of a burning machine, with no way down, and the roof itself getting hotter by the minute. From the ground, the fire chief watched flames rolling out from under the lower frame, 30 feet up, wrapping the base of the machine the way a gas burner wraps around the bottom of an oversized pot. Below him, an aerial ladder truck arrived and couldn't reach high enough. A rough terrain crane with a man basket tried and came up short too. Every option that should have worked didn't, because nobody had ever needed rescue equipment built for a fire this far up a machine this tall. Andrews did the only thing left. He climbed higher, up onto the gantry, away from the worst of the heat, and waited, with nothing beneath him but 210 feet of burning steel. Miller talked him through it from the ground. Put on a safety harness. Snap it onto one of the steel suspension cables running from the gantry to the top of the boom. 2-inch cable, the kind built to hold thousands of pounds of tension, never designed to be walked like a tightrope by a man escaping a fire. Andrews did it anyway, cable by cable, unclipping and reclipping his harness at each stabilizer block. He made his way across open air, 21 stories above the pit floor, until he reached the top of the boom, where he could finally walk down the boom steps to where the man basket could reach him. He came down alive. So did Miller, and so did Kruger, who climbed back up the boom afterward, just to be sure his operator made it down safely too. Nobody on that crew was seriously hurt that night, but by the time the fire was finally beaten back near 2 in the morning, the lower works of the largest machine ever built were gutted, and the fight wasn't over. Heat had melted seals in the swing gear cases, releasing more oil to feed the flames back to life. It burned another 3 hours before crews finally called it out, close to 5 in the morning. By daylight, it almost looked survivable. Miller himself said it. From a distance, aside from some blackened panels near the bottom, the captain looked normal. Climb up into the cab, and everything still looked untouched, just smoke residue on the surfaces. For a moment, there was real hope this could be repaired. Then came the second inspection, the one that mattered. The fire hadn't just burned the surface. It had burned for hours, fed by thousands of gallons of hydraulic oil, hot enough to weaken structural steel and crack the machine's main revolving frame. A floor plate 5 inches thick, split clean across from one side of the machine to the other, likely from the sheer thermal shock of firefighters' water cannons hitting overheated metal. The lower works, the electrical systems, the hydraulic network that had kept this machine alive for 26 years. All of it, gutted beyond economical repair. Nobody ever confirmed exactly what started it, not with complete certainty, not even after the insurance adjusters finished picking through what was left. One theory pointed to oily rags catching a spark thrown off an electric motor somewhere in that crowded lower deck. Another, the one that stuck hardest in the years after, blamed a hydraulic line that had simply given out under pressure, misting hot oil into the air until a spark from a nearby motor found it and lit it like a fuse. Whichever it was, the mechanism was almost insultingly small, somewhere in that maze of 20 electric motors, 30,000 horsepower, and 14,000 volts of current. All it took was a failure the width of a garden hose to bring the largest machine on Earth to its knees in a single night. Think about everything this machine had already survived. 26 years of continuous 3-shift operation. Millions of tons of overburden torn loose and swung through the air. Winters cold enough to crack lesser steel. Summers hot enough to cook a man alive in that machinery deck. and not one structural failure serious enough to stop production for more than a routine repair. The captain had outlasted mountains of rock, outlasted competitors, outlasted almost every prediction ever made about how long a machine this size could keep working. And none of that mattered. The night one length of rubber hose gave out under pressure, it had probably handled 1,000 times before without incident. That's the fact this whole video has been walking toward. 28 million pounds of engineering, and the thing that ended it wasn't a rival machine, or a mountain that finally fought back, or even human error at the controls. It was a hose, a part small enough to hold in 2 hands, feeding a fire that 100 firefighters and 30 pieces of equipment could not fully extinguish for 10 hours straight. Where the captain sleeps now, Marion Power Shovel got an estimate for repairs after the fire. $7 million, and that number came with no guarantee the machine would ever run at full capacity again, not with a crack running clean through 5 inches of structural steel. Arch Coal had a decision to make, and it wasn't really a difficult one. They already had a replacement shovel, smaller and slower, but working, brought over from a nearby mine within days of the fire. The captain, meanwhile, sat frozen mid-swing over the pit, its bucket never lowered again. The insurance settlement came to $35 million from Lloyd's of London, more than enough to cover the loss on paper. What it couldn't cover was 26 years of history, a mile of pit dug in 10 days, 809 million cubic yards of overburden moved over a working life longer than most human careers. In 1992, a salvage crew arrived and began cutting the largest machine ever built into pieces small enough to haul away, in the same pit where it had spent every single day of its working life. Nothing of it was preserved. No museum wanted a machine this size, and nothing about the wreckage was stable enough to move intact, even if one had. The bucket that once swallowed a house in a single bite went out the same way as every other piece of it, cut into scrap small enough to fit on a flatbed truck. Other giants of this era at least got a fighting chance at a second life. Years later, preservation groups would rally around another retired stripping shovel, raising money, organizing pledge drives, trying to keep at least one of these monsters standing as a museum piece instead of scrap. Even that effort failed in the end. The machine dropped by explosives when the money ran out. The captain never even got that chance. A machine gutted by fire, cracked through its own main frame, sitting on land actively being reclaimed for coal, was never a candidate for saving. It went from the largest machine on Earth to scrap metal in the space of about a year, with nobody organizing so much as a petition to stop it. There's a strange footnote sitting underneath all of this, one that makes the ending land even harder. Around the same years Marion built the Captain. That same Ohio company was trusted by NASA with an entirely different kind of giant. Marion's engineers designed the crawler transporters that carried the Saturn V rocket to its launch pad, machines built on the same stripping shovel undercarriage technology that moved the Captain across an Illinois pit. One arm of this company built the vehicle that helped put a man on the moon. Another arm built a coal shovel that a garden hose could kill, decades later, in a pit most of the country never heard of. Bigger, it turned out, didn't mean safer. It just meant different things could go wrong, at a scale nobody had fully priced in. What replaced the Captain, in the end, wasn't a bigger machine. The industry that built it was already changing by the time it burned. Cleaner energy sources coming online, tighter environmental rules taking hold, a coal market that would never again justify building something this reckless in scale. The era of chasing bigger, the same 80-year obsession that started with 3 men in a machine shop in 1884, effectively ended with the Captain. Nothing built after it ever tried to outmonster it. The record for largest mobile land machine stood, more or less unchallenged, because nobody in the industry saw the point in building something that fragile again. Marion Power Shovel itself didn't outlive its own creation by much longer. Sold to Dresser Industries, spun off, sold again, and finally folded into its 100-year rival Bucyrus in 1997. which closed the Marion, Ohio plant for good. The town that had once produced 90% of America's large excavation machinery went quiet. The factory floor that built a machine capable of moving a mountain with 4 pairs of hands stopped building anything at all. Ask Gene Miller today, and he won't tell you the captain was a mistake. He'll tell you she was a wonderful machine, that nothing on that mine could touch her for production, that he ran a mile of pit in 10 days and never once doubted what she could do. That's the part of this story that's easy to miss, underneath the fire and the fear, and the men climbing cable above the flames. For 26 years, 4 people ran the largest machine on Earth, and it never once failed them by force. It failed them by accident, in the space of a single evening, in a way none of their training or their instincts, or their 26 years of near-flawless caution could have prevented. What's left of the captain today is a handful of photographs, a spec sheet in a company archive, and the memory of 4 men who spent a night climbing steel cable above a burning machine to stay alive. The lesson underneath all of it isn't really about coal or steel or horsepower. It's about what happens when you keep building bigger without ever building in a way to fail small. Every ounce of ambition that made the captain the largest machine on Earth is also what made it impossible to save the night something finally went wrong. They don't build them like that anymore. Not the machines, and not the 4 men brave enough to run one.